580 Quantitative Data Analysis, which will be a course about machine learning in finance and economics. Okay? So I would like to welcome you all to this course, and it's a pleasure for me to teach this course for you. I hope you are all healthy and safe during these turbulent times. Okay? So let's first introduce myself. My name is Marcelo Medeiros. I am professor of economics in Brazil at the Pontifical Catholic University of Rio de Janeiro, and I'm also a visiting professor of economics at Princeton University. Okay? I have been teaching this course for a couple of years, okay? And my research interests are related to econometrics, machine learning, forecasting, and empirical finance. Okay? Here you have all my contact. You can reach me by email, and I invite you to check my website where you can see a little bit of my research. Okay? So the idea today is to give an overview about the course. So this course will cover the most recent advances in statistical machine learning theory, and we'll explore several aspects in finance and economics. I'm going to show you a lot of applications in these two areas. Okay? And overall, the topics covered will include shrinkage estimation methods such as Ridge and the lasso, and of course the many extensions of the lasso. We are going to see also ensemble methods like bagging and boosting, nonlinear models such as random forests, neural networks. Then we are going to move to deep learning and deep neural networks. We are going to see also classification, support vector machines, clustering, and dimension reduction and factor model. So it's a very ambitious table of contents. There's a lot of material. Some of these topics could take a full course on it. So the idea is to give you a hands-on view of these different methods, but also provide you as the theoretical background that justifies the applications of these methods in practice. Okay? About grading criteria, I'm going to talk a bit about it. You're going to have homework assignments, and this will represent 40% of your grade. Okay? There will be a midterm computational project, will be an empirical project that we are going to take the data and analyze data, and this project will be 30%. And then you're going to take a take-home final that will be a mix of a computational project, an empirical project, and some theoretical questions, and this will also represent 30% of the grade. Okay? So there will be like 4 assignments. So if you take a look at the syllabus of the course, all the assignments are explained. You are going to have like 2 weeks to prepare your assignments, okay? And these deadlines won't be changed, so you have to plan ahead of time how you're going to do these assignments, okay? So there will be 4 assignments that will be graded, but we are going to have an extra assignment in the beginning of the course that will serve as a guidance. Okay? The idea is to guide you on how to prepare the assignments that will be graded. So in this first assignment, I'm going to guide you through the data sets. We will be analyzing in most of the assignments the same data set. So I'm going to show you how to prepare this data and to use during the assignments. Okay, so it will be very important that you take the first assignment very seriously. About reading list, so I'm going to show you a couple of books. There are 2 books that are heavy on theory, so everyone that are really interested into the theory of machine learning or of high dimension statistics should take a look at these 2 books. One is by Peter Buehlmann and Sarah van der Gier, Statistics for High Dimensional Data. It's a classic book where most of the derivations that I'm going to show you during the course are in this book. And we have also a book by Professor Jianxin Fan and co-authors about statistical foundations of data science. It's a very new book. It's a 2020 book with several advances in the theory of machine learning method, and it covers from regularized regression up to deep learning methods. So it's a very complete and very good book. Also, all the theory is in these two books. Okay. If you want something that's more soft reading, I strongly recommend The Elements of Statistical Learning. This book, in fact, you can download from one of the author's webpage. So from the webpage of Trevor Hastie, you can download the PDF copy of this book. And it's a very nice introduction to statistical learning theory. So if you are new in the field, if you didn't take a course before, I recommend you to start reading this book because it's a very nice and clear introduction to the field. As a complement, there are other books also from the Stanford author, the Stanford professors. All these books are again available for download from Trevor Hastie's webpage. So we have statistical learning with sparsity, where it's a little bit deeper than the previous one. You're going to have some more theory into that. If you wanted a more practical take and implementations in R, we have an introduction to statistical learning with applications in R. And finally, a computer-age statistical inference that gives you a more algorithm approach to all these methods. So these are very, very good books. Of course, the lecture notes are self-contained, and you don't need the books to follow the course, but if you want to take a step, an additional step, and learn a little bit more and learn some topics into details, I recommend some of these books, especially the first two, where you're going to have more theory and all the derivations. So if you are interested into theory, in doing theory for machine learning and high-dimensional models, I strongly recommend these books. And of course, there are many, many papers in several journals. I'm listing here in the screen some of these journals. So also I'm going to complement the material with some papers that I think will be important to the course. In terms of software implementations, you are free to use any software you wish. The only thing that you have to code, so you need to have some previous knowledge in coding. If you're going to do the assignments in MATLAB, R, Julia, Python, it really doesn't matter. Pick your favorite and stick to it. Okay, and we are going to be interested in the results of your implementation, the results that you are going to have, and the analysis that you are going to make. It doesn't really matter how efficient is your code or which kind of programming language you are using. For instance, I'm a MATLAB person. I code mostly in MATLAB and R also, but mostly in MATLAB. But if you want to do Python, we are going to give you also support for Python. So we can help you with MATLAB, R, and Python if you wish. And for MATLAB, for instance, there are several toolboxes, very interesting toolboxes, the statistics and machine learning toolbox and the deep learning toolbox, where you're going to see implementations of most of the models that we are going to see in this course. And for R, probably the most famous package is GLMNet. And if For nonlinear models, you can check the R-bloggers webpage, where you have evaluations of several other packages that are completely free, that you can download from the web, and where you can estimate linear and nonlinear machine learning models. Or you can also try the HG Econometrics package that has been developed by one of my previous students. Okay? For Python, I recommend you to check this web link that's appearing in the screen here, where you're going to see many resources in terms of packages, libraries for Python to use with machine learning methods. So, as I mentioned, you need some knowledge of a programming language. It doesn't matter which language it is, but you need to know how to code a basic program. You don't need to be extremely efficient programmers, but it's important that you have a basic knowledge in coding. Okay? And of course, knowledge of probability and statistics, like a first course in probability and statistics, calculus, and linear algebra. We'll be using these tools all over the course. It will be very good if you have some previous knowledge in regression analysis and time series models, like ARMA models. If you don't have it, it's not a problem. I can provide you with some references, but if you have, it's better. If you want to refresh a little bit your knowledge about basic econometrics at a graduate level, I recommend these lecture notes by Bruce Hansen from Wisconsin. Professor Hansen has a very, very good online book. The link is here, and it's a very complete book, so I strongly recommend to anyone interested in learning more about econometrics. The book starts from the basics and go up to very advanced topics. Okay, so this is the end of the first block of lecture 1. This first lecture consists of 4 blocks, 4 different videos, okay? And each video is self-contained, okay? And each video has different length. So it's the first one, you have more 3 to go, and I strongly recommend you to watch all the videos before our next meeting. Okay, thank you. See you in the next video.